In this video, what I would like to do is work another example of finding forces along lines. And I'm actually going to be looking at two different forces. I'm going to be looking at one force that points from A to B and has a magnitude of 20 pounds, and another force that points from A to C and has a magnitude of 40 pounds. And what I'm going to be looking for is I'm going to be trying to determine the magnitude of the resultant force and the coordinate direction angles that this resultant force makes. I've also tried to indicate in space using these dashed lines where these points are located in space. So where point A, where point B, and where point C are located in space. And that's the first thing I want to try to determine. So in a problem like this, I look at important points that jump out at me, and I try to note what their X, Y, and Z positions are. So if I look at point A, what point A is, well, I'm not going anywhere in this X direction, so X is going to be 0. I'm going 2 feet in this Y direction. Now, this Y direction is positive is to the right. I need to go to the left, so this is going to be a -2. And then I have to go up 4 in the Z direction, and it's in the positive Z direction. So point A is going to be located at 0, -2, 4. Now we can do point B. Point B, how far do I need to go in the X direction? I need to go in the positive X direction, 1.5, and the minus Y direction, 3, and I don't need to go anywhere in the Z direction. So this is going to be 1.5 minus 3, 0. And then we can look at point C. Now point C is a little bit more interesting. I'm not told how far I need to go this way and this way. I'm just told that the distance from the origin to point C is 2 feet, and this 2 feet makes a 20-degree angle with the y-axis. So when I see this, I see a right triangle. I see I can have this right triangle right here, and I can figure out with sines and cosines what these distances are. So let's draw this right triangle just to make it a little bit more clear. So here, this is going to be 20 degrees. This is going to be 2 feet, point O, point C. And now, what are these distances? Well, this distance is going to be my Y distance. This distance is going to be my X distance. And I do need to remember, and I'll take care of it later, that I am going in the minus X direction. So let's look at this. X is going to be equal to 2 times the sine of 20. Y is going to be equal to 2 times the cosine of 20. So let's go and let's calculate what these values are. So 2 times the sine of 20 is 0.684. 2 times the cosine of 20 is 1.88. So point C is going to go in the minus X direction. It's going to go 0.684. It's going to go in the Y direction, we'll say 1.88. And how far do we have to go in the Z direction? We don't have to go anywhere in the Z direction. We're already there. So it's 0 in the Z direction. So now that I have figured out the points A, B, and C where they're located, I want to break up my forces, the 20-pound force and the 40-pound force, into their components. If I can break them up into components, I can combine like components. And then if I can combine like components, I can figure out what the magnitude of their force is. And from there, get the cosine angles. So that's my game plan. So here, we have to do this for both forces, but I'm going to do the 20-pound force first. And just to refresh your memory, if you forgot, a force along a line, and both of these forces are along a line, is equal to the magnitude of the force times some position vector, and that position vector is going to be where that the line points. So R, over the magnitude of that position vector. So with this 20-pound force, we'll say this is the force of 20. This is going to be equal to the magnitude, which is 20, times this position vector. And this position vector points from A to B. So this position vector points from A to B. I'm going to say, okay, my position vector A to B is my position vector of B minus my position vector of A, right? I subtract the head from the tail of this vector. So we're going to have these B's minus A's. So 1.5 minus 0 is 1.5i. Minus 3 minus a minus 2 is a minus 1j. And then a 0 minus a 4 is a minus 4k. Now the magnitude of this is going to be equal to the square root of 1.5 squared plus minus 1 squared plus minus 4 squared and we take the square root of that, and this is equal to 4.39. So now I know my position vector. It's going to be 1.5i minus 1j minus 4k divided by 4.39. Now I can calculate and simplify this a little bit. So I'm going to do 20 times 1.5 divided by 4.39, 20 times minus 1 divided by 4.39, 20 times minus 4 divided by 4.39. 20 times 1.5 divided by 4.39, 20 times minus 1 divided by 4.39, 20 times minus 4 divided by 4.39. And so my force of this 20 pound force is going to be 6.83i minus 4.56j, and then we have minus 18.22k. Okay, so we did the 20-pound force. Now we have to do the 40-pound force. And this 40-pound force, we do the exact same procedure. So we're going to have the force, the vector, is going to be 40 times, now we need to figure out the position vector of A and C. Well, we're going to have our position vector, I hope I've left enough room, is equal to RC minus RA. Again, we subtract the head, the tail from the head, so we start at where the head is. That's point C. And this is going to be equal to minus 0.684 minus 0. So minus 0.64i. Then we're going to have 1.88 minus 2. 1.88 minus a minus 2. So we're going to be adding 2. So that's going to be 3.88j. I didn't give myself enough room. And then we're going to have 0 minus 4, so minus 4k. And now we need to take the magnitude of this again. So the magnitude of our AC is going to be equal to the square root of minus 0.684 squared plus, minus needs to be in the square, plus 3.88 squared plus minus 4 squared. So this magnitude, that doesn't, plus minus 4 squared. I need to take the square root of this. So this magnitude is going to be 5.61. So we can write this same expression. So 40 times minus 0.684 plus 3.88 minus 4 divided by 5.61. Evaluate this just a little bit, simplify this out, calculate this out. So I'm going to have 40 times minus 0.684 divided by 5.61. I'm going to have 40 times 3.88 divided by 5.61. And I'm going to have 40 times minus 4 divided by 5.61. So now this is going to be equal to minus 4.87 I. Oops, I forgot these here. So this is an I, this is a J, and this is a K. So minus 4.87 I plus 27.6 J minus 28.5 K. And so now we have our force of 40 and our force of 20. If we're trying to figure out a resultant force, so this resultant force right here, we're going to add both of these forces up. So we're going to combine our forces. We're going to say this is equal to F20 plus F40. Now this is going to be equal to 6, let's try to keep it consistent color-wise, 6.83 I minus 4.56 J minus 18.22 K. And then we're going to have plus a minus 4.87 I plus 27.6 J minus 28.5 K. We can combine these like terms. So this is going to be equal to, and now colors are not going to be consistent, 6.83 minus 4.87 I plus minus 4.56 plus 27.6 J plus minus 18.22 minus 28.5 K. So now let's combine these. So this is going to be 6.83 minus 4.87, 1.96 minus 4.56 plus 27.6, 23.04 minus 18.22 minus 28.5 minus 46.72. Okay, so 1.96i. The calculation, I have the recording over here, so I don't have the calculator up. So I have to keep looking over here to see what the calculation was. Plus 23.04j minus 46.72k. And now we can figure out the magnitude by taking the square root of these numbers. So my magnitude, FR, is going to be the square root of 1.96 squared plus 23.04 squared plus a minus 46.72 squared. So let's do that. 1.96 squared plus 23.04 squared plus minus 46.72 squared. Take the square root of this number, and we get 52.13. So this resultant is 52.13, and we're in pounds. So that's half of what I'm looking for. The next thing that I want to look for is I want to solve for my direction angles. So solving for my direction angles, I remember the equations I have. I have the cosine of some angle alpha, which is the direction, the cosine direction angle I make for my positive x-axis, is going to be equal to the x component of my force divided by my magnitude. So I can solve this. I can say alpha is equal to the inverse cosine of the f component, 1.96, divided by the magnitude. I can say that the beta angle is going to be the y component divided by the magnitude, and my gamma is going to be the z component divided by my magnitude. And remembering, alpha is the angle from the x-axis, beta is what I defined as the angle from the y-axis, and gamma is what I defined as the angle from the z-axis. So we can solve for all of these. So this is going to be 23.04 divided by 52.13, and gamma is going to be minus 46.72 divided by 52.13. So let's put these in the calculator. So we have the inverse cosine of 1.96 divided by 52.13. The inverse cosine of 23.04 divided by 52.13. And the inverse cosine of minus 46.72 divided by 52.13. So these values are going to be 87.8. It's going to be 63.8. And it's going to be 156.7. So these are my coordinate direction angles. If you like this video, please consider subscribing to my channel and liking this video. It will help increase the visibility of my channel and make this video easier for others to find.